Hi everyone, welcome to part 2 of finding the RNS configuration. Let's go over some examples together. So we have this molecule right over here. It is called 3,4-dimethyl-1-pentene. So first, as always, let's try to find the stereocenters. And by the way, feel free to pause the video and work on the problem first and then see if your answer is comparable with mine in the end. So let's look at this carbon right over here. Is it a stereocenter? It is not, because it has these two methyl groups, meaning it doesn't have 4 different substituents. Is this carbon a stereocenter? It is, because it has 2 different R groups right over here, this alkene and this alkyl group. And then we have this methyl, and then, oops, sorry, this is supposed to be a hydrogen. And so indeed, it does have 4 different constituents, so it is a stereocenter. Let's try to find whether it is an RS configuration together. So first, when assigning priority, which R group would get first priority? This alkene group or this alkyl group? This alkyl group or this alkene group will get first priority, then this alkyl group, then methyl, then hydrogen. So let's redraw this to organize it better in their heads. We'll call this R1 and we'll call this one R2. It is rotating this way. So this is going to be an S configuration. Perfect. All right, let's go on to the next problem. This problem is also written in our Fisher projections, which will make it super simple for us. First, as always, let's try to find the stereocenters. I see 2 right over here and right over here. And let's assign priority first. Let's do this carbon 1. We'll do. So this bromide gets 1, then this R group, this carbon R group gets 2, CH2Br gets 3, hydrogen 4. Alrighty. And if you didn't watch my previous video, well, you should. I go through the first 3 problems and I kind of briefly go over the Fisher projections. But basically, this is equal to and because our first priority atom is facing towards us, we can try to find the configuration simply without having to manipulate the bonds. So it goes 2, 3, 4. It's rotating that way. So it's going to be S configuration. And right away, you can tell that this is actually a meso compound, meaning that this segment and this segment are mirror images of each other. So right away, you can deduce that this carbon is the R configuration, but we can just double check. This is 1, 2, 3, 4. And so as you can see, it is rotating this way. So indeed, we're correct, and that is our configuration. Perfect. All right, let's go on to the next problem. This one is also 1, 2, 3, 4 tetrabutane, like our other one, but its stereochemistry is different. So those are the stereocenters. Let's do the same thing. Assign priority. 1, 2, 3, 4. And the bromine is still facing out towards us, so no need to manipulate anything. It is rotating that way. So this one is going to be an S configuration. Now let's look at this carbon. 1, 2, 3, 4. Is rotating that way. So this one is also going to be an S configuration. Perfect. Right. Next, we have 3-bromo-2-butanol, and this one is also in the Fischer projections. First, let's find the stereocenters right over here, right over here. And let's first find the configuration of that segment. So it'll be 1, 2, 3, 4. It is rotating this way. So that is going to be in S configuration. And now for this carbon right over here, let's assign priority. 1, 2, 3, 4. It's rotating this way. And so this is going to be an R configuration. All right. Next, we have a problem in Newman projections. Okay. And this molecule is 2-bromo, 3-fluoro, 2-butanamine. So how I like to attack problems that are presented in the Newman projections, I like to first pretend as though I'm twisting the bond back that way so I can clearly see the carbon-carbon bond. So first, let's observe the molecules that are in front of us. So if we pretend that we're turning the molecule that way, then this methyl group is going to be behind us. The amine is going to be facing towards us, and bromide is along the plane. And then now if we're going to observe our back molecules, the hydrogen is going to be facing out away from us, the methyl towards us, and the fluorine is also going to be along the plane. Okay, so let's look at this carbon right over here first. First, let's assign priority. Bromide 1, because highest molecular weight, then our amine, then our R group, and then our methyl. So let's put our first priority atom on top. It is rotating this way, so that is going to be an R configuration. For our front molecule. Next, let's look over those bonds. So we have fluoride, R group, hydrogen, methyl. Let's assign priority as always. 1, 2, 3, 4. And the fluoride, our first priority atom is already on top, so that's super convenient for us. So it's going to be rotating that way. So this is going to be in S configuration. Perfect. Next, we have this problem. As always, try to find stereocenter. Well, as you can recall, the stereocenter definition is the carbon would have to have 4 different constituents. And none of these carbons have 4 different constituents because it is an alkene. So there would be no way in trying to figure out whether this is an RS configuration.